Okay, welcome back. Today we have a U5000 that is in vertical collapse. So this makes our job here somewhat easier because we know that if it powers up, we don't have to worry about all the power circuit and checking all the components and everything. We can just check the vertical deflection components and hopefully get this up and running. And of course we'll have to do a full reflow and everything that we normally do on the video selector header pins and things, and we'll show that here in a moment. I'm sorry if it's a bit loud. I already have my desoldering station running in preparation for having to take components out and things, but the first thing first here is we're going to have to open this up and do some inspection and make sure everything is intact. Okay, get that out of the way. Let's go ahead and just take this off of here. Alright. Pretty dirty, but otherwise I don't see any broken pots, so we'll consider that a win. I hate packing tape on the bubble wrap. I don't know why people choose to do it that way, but it's what they do. Alright, and any casualties on the neck board? Other than, yeah, those are all bent to hell, common. Neck board not protected too well, but again, common. Well, I can already tell you the caps are original, so we're probably going to end up having to cap this thing. Our linearity coil the coil's not broken, but it's bent and out of whack like almost always. You can see the magnet here. This magnet is required for the linearity to function the way it's supposed to, and it should be, you know, sitting like that. I'll have to glue that all back in place, but that's not a problem. But it's a common issue from shipping these things. This here doesn't look very normal. That's not a normal setup there. But if we look here, look at how burned and heat damaged this is. Absolutely common on the U5000. So yeah, that is the 25 kilohertz selection. So this has obviously been running on a medium resolution setup. So I'm going to see if I can possibly replace this connector. We may have to replace the pin on here because it's probably all burned up, so I'll have to take that out of there and inspect that. But I imagine that if we push down and slide this off of here, we can look at the back side, and yep, look at that, exactly as I suspected. Look at this solder joint here. Completely cracked and broken. On almost every U5000 you come across that has issues, it's almost always one of these header pins is cracked and broken. This one's cracked as well. It's not even in use. Look at that one, and this one, and usually it's the ones down here as well. But that one, those two seem somewhat okay. The rest of these not so bad, but that one, yep, that is bad. And that one corresponds to, I think, this very first one. Yeah, it's the very first pin. This very first pin here. But that is the absolute most common issue with the U5000. Those header pins having cracked solder joints from the heat caused by this. So I'll see if I have a donor board that I can steal this connector from. I may have a connector already. How many pins is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I don't have an 11 pin, but I'm pretty sure I have a 10 pin. I'm not going to be able to make a 10 pin work though. We'll see what we can do. But it was reported as vertical collapse, and it may simply have something to do with that bad solder joint. I don't know. So we'll test our other components here. So it's very simple in the vertical circuit. Let's get rid of this connector first here. Every time, does not want to come off. And our neck connector, there we go. We'll get this out of here for ease of work. But our we're gonna have to rebuild this as well. This is all foobarred. I'm sure it probably works, but we'll see if we can't super glue these pads back down and get this functional in a more practical application, because these are all bent over as well. So that'll be a separate thing along with getting this up and going. So let's go ahead and just test our normal components. There's R303. This guy right here, R303, if that is out of tolerance, then we'll have vertical collapse. So let's test R303. Should be 1.2 ohms, give or take, and it reads 1.3. So R303 is not the problem. D302 is right underneath it. If that is open or shorted, I should say, that'll be collapse. So let's check D302 here. That's good. Our next step is those two are for HOT. Next step would be D603. There is a diode right here. If this diode reads both directions, then our IC is shorted. So if we go to here, we should read our normal diode voltage drop, 0.5. If we can get this in frame here. There you go. Now if I switch the leads around and it reads the same thing, our IC is shorted. And it is not. Or it doesn't read the same. So our IC is not shorted. We can go ahead and test and make sure by going to all the pins, I believe. If I go to ground here, which is right there, and if I go to, I believe, this pin here, pin 5, 1, 2, 3, 4, 5. Yeah, pin 1, 2, 3, 4, 5. Pin 5 is ground, that's how it should be. But if we go to, I think, which one of these is 1? I'm pretty sure that 1 is on the left here. So again, if we go to 1, 2, 3, 4, 5, that's supposed to be ground. But if we go to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our IC is not shorted. I can't guarantee it's good, but it's not shorted. So the most common issues for vertical collapse actually check good. R303, D302, D603, and our vertical IC. None of that reads bad. Those are the most common issues that cause collapse. It could be caps, it could be something else, but I'm betting that it's this bad jumper here. So what I think we're going to do is I'm going to fix all this. I'm going to reflow all the pads here for the jumpers, the header pins. I'm going to see if I can replace this connector. And then without doing anything else, we're going to fire it up and see what it does. I'd like to fix this. It doesn't need to be fixed beforehand, but I'm going to at least kind of redo how these sit here. That's a bit better. These are always bent around. Okay, I think that'll work for now. Let's go ahead and put these all to center. That was turned completely down, shouldn't have been. Actually, I'm going to put all these about 25%. I've said before that the 7400, 7500, 2000, 5000, they don't really like having these color pots up more than about 25%. So I'll put them about 25% here. That's all the way up. We'll go to about 25%, 25%, 25%. The drive pots will leave it about 50. So let's do that, and then as far as our connections, let's verify that these actually are good here. Here to here is good. Here to here, good. There to there, good. Here through to here, here to here, here to here, through to here. Alright, so as bad as that is, all the connections are good, so I think we'll just go ahead and, like I say, I'll worry about this later. For now, let's go ahead and get these header pins reflowed, and possibly, you know, I think I may just remove the connector completely so I can clean off the pins and make sure that's all good. And then I want to see if I can go find a donor connector, because I want to replace this connector. So let's go ahead and get these header pins and connectors off of here and clean those up, inspect all that, get them back in, get it all reflowed. Then I'll try and replace this connector, and then we'll hook it all back up and see if it's still collapsed, and if it is, we'll troubleshoot further. If not, then it was that broken solder, this completely cracked and broken solder joint. Yeah, because that's pretty amazing there. This one almost as well. So this is obviously spent most of its life in medium resolution mode. Okay, so let's go ahead and just desolder these. All right. Got a large plane here. It's tough to get the solder to flow on these pads here that have this large plane because it soaks up so much of the heat, and there's not much of a surface area on the head of this desoldering gun. Come on, there you go. Alright, that should be the standard resolution connector. So I'm taking these out of here so I can clean off the oxidation and whatnot on the actual pins themselves. Okay, I think that should work. So let's clean this out before we... There we go. Set it back in the holder, and these should come right out now. There you go. There's one. Man, that is pretty heat soaked. And then here's the standard. There it is. Pretty easy. It appears that the heat has even crossed over onto the standard one. Alright, so now... Wow. Okay, well, let's grab our fiberglass pen and try to clean these up a bit. Actually, I'm gonna do it over here, so... So when you plug this in, the sockets actually make contact with this side of the pins. So you really only need to clean off this side of the pins, because when you plug this into here, the sockets make contact with this edge along this side. So we're only really interested in cleaning up the outside edge of that, like there. So let's grab this other one. Do the same to it. And I'm doing this over the rag so I can just, fumble the rag over the trash can to get rid of all these fiberglass bristles that brush off of here. Otherwise they end up in my hands and my forearms and everything, and it's not fun. So, okay, I think that should work. So those are done. I can go ahead and put them back in, I suppose. Alright, so let's start with the standard res one. And we're going to have to tack it in place here. Alright, I gotta get my fan going. There we go. Okay, now our medium res connector. I mean, ideally you don't have to really replace these, even though they're burned up a bit, because like I say, if we clean off the corrosion and the oxidation and everything off the outside of the pin to make a good contact, when we replace this connector and clean off the pins off of this, then it should be good to go. Alright, so let's solder these in here. Not sure why some of these are sitting higher than they should. Which one of these was... There we go. Why these are sitting higher, I don't know. Whoop. Too much. There you go. Okay, that's better. Those are all okay. Why that's like that? Let's. All right, that'll work. Okay, now. Okay, well there you go. That is how I would recommend doing that. Okay. That's better looking there too. So there you have it for that. I think that is good to go. Anything else here I should hit? What the hell? Look at that. Why is there good solder on all these flyback joints except this one? Why is that one joint, like somebody reflowed this, but they forgot to get, look at that. Get a better angle on that. That's why. Well, let's it doesn't look like it's bad. It doesn't look like it's bad. But why would they? There's almost no, there's a bunch of pieces on here that shouldn't be. Why? That's just odd. Well, let's hit that. That's better. There you go. Huh. Weird. Okay, let's look at this again here. Anything else we can find? This cap has been changed. But another thing that you always want to look at is your main power connector, your input here for your AC. If we look at that, the solder joints on these connections are almost always bad as well. And these aren't too bad, but they could stand a good reflow here. we go. That's much better. Okay, well, I think let's tackle replacing this connector. And see what we can do about that. As far as taking the pins out, it's quite simple. You just push the little keyway in here, and then it should come right out. I shouldn't be doing this with a razor knife, but there you go. Then you can just take your little razor knife and bend the lock back out. You see how the lock is flat there. If we take this and just bend it out, there you go. Now it's back out again. So then you just put it in your new connector and you're golden. Now I don't know if I got a bunch of these sockets. I don't know if I should replace all these, because it's not really necessary to replace them when you can just take your fiberglass pin here and clean off. See how that should be silver, not black. So if we just take our fiberglass pin here, you don't necessarily have to replace these. You just do this. And there you go. That's all you have to do. So I'm probably not going to replace these pins because you don't really need to. That's all you need. And when they actually go in the connector, they will sit right up against here like this, that we just cleaned this edge on. So I think we're going to be good to go. So let's just see if I'm going to cut away here and see if I can find the replacement connector, and then we'll swap all these pins over, and then we'll put it back together here and see if we can get it to work. If we hook it up and it's still collapsed, we'll do a bit more troubleshooting, but it may be capacitor related. So if we hook it up and it's still collapsed, we don't find anything else in our troubleshooting, I'll just toss the cap kit on it and we can kind of go from there. In the meantime, I'm going to see if I can fix this, glue this linearity coil back in place too, because I don't want to lose this magnet in here. It should just sit like that. I think I'll just glue that back in place as well. So, all right, let me cut away, see if I can find a connector. When I come back, we'll get this repinned here. Okay, so I dug through my stash and I have a donor 5000 here. As you can see, it's pretty much been robbed of a bunch of stuff. And no neck board, it's just a loose U5000. The vertical sweep mod has been stolen and I've used it for various things. And we just happen to have a connector on it that has a little bit of heat damage, but not nearly as bad as the one we have. So we're going to rob this and use it. And in all likelihood, it's probably going to be easier to just desolder our red and brown wire and swap it over without having to do anything, because this is I still want to pull out, well, if we have, you know, I think I'll just take out these first 3 wires. I'll take out these first 3 wires, clean the pins on there like I showed you on the other one here, and then we'll just desolder the red and the brown wire and move the whole assembly over without having to depin all the rest of these pins. It's going to be much easier that way. So let's go ahead and just take this out of here. All right. Okay. And I'll transplant this one back over to here, so at least we have a connector in the future if we need one. But you know, for this repair, since this one doesn't belong to me, it's being done for somebody else, I'm going to do this a bit better than I would have if this was mine. If this was mine, I would just reuse this connector, clean all the sockets, and just put it back on, because if it's clean on both this contact and the main chassis contact, it doesn't really matter that it's discolored. But I don't mind doing this a bit better for this person, so we'll do it this way. Okay, so let's set this aside now, and let's take out these first 3 . And yeah, see, this one isn't even nearly as bad. This one is still somewhat shiny. These aren't nearly as bad as this original one was, but we can go ahead and clean that off, and look at that, much better. Now let's see if we can push this back through. I got a little bit overzealous with that. Okay. And there you go. It is bent back out. Now our lock is re-engaged. So there's that one. And then this is just a jumper. So let's put this back in here. Click. Alright. Now the rest of these. Okay, there's that one. Again, I pushed the lock a bit too much, but that's okay. We'll just pop it right back out there. There you have it. Okay. And let's clean off this one. Nice. All right. Put it back in here. Click. Okay. Now we got to get this one out of here. Oh, come on. There we go. All right. And push that back through. Grab it and there you go. Alright, and this one is not too bad, but should be like that. Put it back in here and click. There you go. So all of them are back in, they're secure, and I think the rest of these are probably okay. It's just those first three that were part of this heat area. I think the rest of these are just fine. So now what we can do is desolder the same thing from this board. This might not work. Let's do it this way. Okay, let's just do it this way. Take that out of there. Then we'll use this to clear the hole. There you go. Brown's at the edge. Okay, now the red one is right here. Clear that hole. Okay. All right. So we'll take our burned up connector and throw it over here on our donor chassis. We'll put that back in that one later. This one, let's put our brown back in down here. Solder it back in. Okay. And our red one back in here. Solder it back in. There we go. And we'll plug it back into the 25 where it was. Man, that's a tight fit on there. Let's make sure that we're still good. Okay, didn't push any pins through. That should be a good connection. We cleaned everything off and our solder joints are good. Okay, let's go ahead and glue our linearity coil back together. Just a dab will do ya. Alright. Alright, so I'm going to hold this in place for about, I don't know, 3 minutes, and I'll cut away and come back, and then we'll continue on. Well, it took a little bit longer than I expected to get that glue to dry, but it's now nice and secure. You can see it's back the way it's supposed to be. I can move the whole chassis around, and it's nice and secure, so that's done. While I had this tape around here and taped off over here to the heatsink to hold it in place. While that was happening, I went ahead and secured the vertical sweep mod. There's always a hole here in the heatsink with a screw and a nut. So I secured that to the heatsink here so it won't move around or short out on anything. And this is kind of the way it's supposed to be. Most of them just are flopping in the breeze, and I don't know why. Also, this connector here, I've mentioned before in previous 5000 repairs, is that it's a selection here. There's a test point 205. When you're running this chassis on the 15 kilohertz selection, this white wire must be hooked up to this post. You can see there's a white wire and a black wire that's been cut off. For 15 kilohertz, you absolutely have to have this white wire hooked up to this post on, you know, let's zoom in here. You want the white wire to be hooked up to the post like this for the 15 kilohertz operation. You want the post hooked up to the white wire. There you can see how it's lined up with the white wire. But for 25, you have to move it over to the black wire because you do not want this hooked up for 25. And that's how it was hooked up. That's how it was when I got it. It was set up properly, and it was on there you go. Now you can see that the pin is now running to the black wire there's nothing there. That's how it's supposed to be for 25, and for 15 the white wire has to hook up. If you don't, you can damage your vertical IC. So that's the point of this. So it was hooked up like this before. This is how it should be now. So we're good there. We got the sweep mod board secure. We got the coil re-glued in place. We got the connectors cleaned up, the solder reflowed, the connector itself replaced, all of the connections cleaned off with the fiberglass pin. The only other thing I noticed is that all of the caps are original except for this one, the 100 volt 22 microfarad I believe it is, and for the power supply section, this tiny one in there, someone changed that out. And they also changed out this cap here, which is a 1500 microfarad 35 volt cap for the vertical vertical circuit, the vertical deflection circuit. So this cap has suspiciously been replaced. Now somebody might have replaced this trying to fix the collapse. I can't say, but I think the collapse was caused by this. I don't see any other bad solder joints. I don't see anything leaping off of the board at me that says, hey, here's your problem. We checked the normal culprits, D603, R303, D302. You know, there's really not much else that would normally cause collapse on the 5000. There's some other components, I think, on the 7475 2000 that are in this area. That I think there's another resistor here in this location. I don't think it's here on the 5000. I have to go back and look, but let's go ahead just the way this is now with what we've done. I did not test this obviously before we did any work to it. I just assumed that the collapse was correct. So assuming that it does power up and it was collapsed, after replacing the connector and fixing all the solder joints and the pins and everything, let's just go ahead and power it up and see what it does. If it's still collapsed, then we can troubleshoot further and maybe do a cap kit, check for more solder joints or what. But let's do it. Go ahead and proceed from this point that we assumed that these connections were the problem. So let's hook this stuff back up. All right. Okay. All of that. Let's get our remote board and plug it in. All right. Okay, I believe that is it. Everything's hooked up on the neck board. It's hooked up to the main chassis. We got our remote board. All right. Well, let's grab a tube, get this hooked up, and see what we get. Okay, all hooked up, ready to go. We got anode, neck, yoke, ground, video, power, and remote. Verified that nothing is amiss. We have our test pattern generator set to medium resolution. Let's go ahead and turn it on. We've got our meter set ready to read off the B+, which there is on the U5000. There is a, let's go around on this side. There is a little, right there next to that cap is a test point. That's where the B+ test point is for the 5000. So, I think we are ready. Let's turn it on, and A, see if it powers on, B, see what our voltage is set to for B+, and then C, see if we have collapse. So here we go, 1, 2, 3. It does come on, and B+ is 115, a little low. What do we get for video? Focus up. Hey, no collapse. We've got way out of adjustment here. Wow, okay. Let's do contrast all the way down, brightness all the way down. Screen pot all the way. Let's turn the screen pot down to roughly, let's just go there with it. Now let's do horizontal hold. I can't turn the horizontal hold. It's frozen in place. What the heck? There we go. Oh, hey! Look at that! Colors look like garbage. Let's turn up our contrast. Okay. Brightness. Nice. Okay, well there you go. Like I say, I did not turn this on. I really wouldn't have been able to test it because of the bad connections, but I think our collapse was caused by that bad solder joint on the video selection. So there you have it. Quick and easy fix. Per the owner, I'll have to get with him and see if he wants me to do a cap kit, but wow, that is nice and crisp and focused, and wow. It's hard to see through the camera, but let's scroll through and look at our RGB. There it is. Colors are way off, but nice solid RGB. Good screen size. Let's adjust our vertical position a bit down. There we go. Do we have height control? We do in fact have height control. We know our H hold works. Vertical hold. Vertical hold works. H position works. Do we have width control? We do have width control. I think we're good to go. I need to get the B+ adjusted. It's only 115. I'll have to see if I can crack that glue and adjust to 117, but not a problem. Well, all right. Quick and easy fix. I think I've gone over everything I should go over on the 5000 here. I'm going to have to, off camera, I'll have to fix the neck board, get it cleaned up. I'll do that when I get the cap kit done. If the owner wants me to do a cap kit, I'll have to do the reflow. Even if no cap kit is required or wanted, I'll still do all the full reflow, including the connections for the remote board and the 2 neck board connections for the ribbon cable. Anything else that needs it, I'll have to see if I can break the glue loose on the B+ pot. If not, I'll have to replace it and get it adjusted to 117. If a cap kit is wanted, I'll have to do the cap kit and then we'll adjust the B+, because I have to readjust it after the cap kit, which is something you always have to do and verify and make sure. But otherwise, I think that's about it. That's a nice, quick, and easy repair. Let's check everything else here. Convergence looks pretty damn good, but that's of course a tube issue, not a chassis problem. Convergence is good. Back to checkerboard. So, okay, thanks for watching. Hopefully you learned something. I'm glad this was nice, quick, and easy, and then I'll do all the other work if needed off camera. And otherwise, stay tuned for more. I appreciate it, and we'll see you next time. All right. Well, I'm back. About 0.68 seconds after I turned the camera off, I realized, we should probably check the standard resolution as well. So let's go ahead and turn this off. And let's switch, I have to turn this off and switch it to standard. I have to move this connector over to the white wire connection. Oh, come on. There we go. So now that is connected properly there. And then we need to move our video selector from medium over to standard. There we go. And turn this on, and let's see if standard resolution works. Here we go. 1, 2, 3. Okay. And we're at 1.6. We're much closer to 117 now on the standard res. And there you go. It's all off center and everything. I'm not going to bother readjusting because this will have to stay on medium, because that's how it came in. That's how it's probably going to go back into whatever machine it came out of, was medium. So I'm going to not really adjust this, but it looks fantastic. I must say, the colors are a bit off, a bit too much green. I'm not going to mess with it, but this looks fantastic the way that it is. Very vibrant colors and solid image, and it's not bowed and it's not pin cushioned and it's all square and everything is great. So it doesn't really need caps, but they're all original except for 2 of them, so there's no reason not to cap it. These caps are not really good quality from the factory, but it's lasted 20 plus years the way it is. So I mean, caps aren't really needed with how good it looks, but if the owner wants me to do it, I'll do it. So all right, so standard riz works as well. So we have a now successful repair with a 100% operational U5000. So again, thank you for watching. Hopefully you learned something. Stay tuned for more, and we'll see you next time.